Okay, so this question says the perimeter of this whole rectangle is 16 centimeters, so we want the value of x. Okay, so we know that perimeter equals all sides. When you add all the sides together, do you know that about perimeter? You do all the sides added up. Okay, on a rectangle, I'm going to shortcut it. A perimeter on a rectangle would be 2 lengths plus 2 widths, because those are the same and those are the same. Alright, so I know that about perimeter. So here I go. Perimeter equals 2 lengths of 5. So the 5 and the 5 plus 2 widths. All right, and I was also given this. The perimeter was 16. So 16 equals 10 plus 2 of those. Wait, now that I know this, how do I solve? So remember what we kind of thought about last time? Let's first understand how we can get the radical alone. So give me some algebra moves that isolate this root. What should I get rid of first, the 10 or the 2? 10. Minus 10 first. Okay, then algebra. Divide by 2. Okay, so we got, first goal is accomplished. We got the root alone. How do we get rid of the square root? We square, but we have to square both sides if we're going to do that. So 9 equals x plus 8. And subtract 1. So we got an x of 8. And that's it. Number 2. Okay, I've been giving you formulas here. This one is talking about a velocity of an object according to their mass. Okay, so let's think here. Velocity is the v. Do we know the velocity of the object? Yep. The velocity of the object is 40. The E is the kinetic energy and the M is mass. We have been given the mass of the object. So that is 0.5 for the mass. Find the kinetic energy. So 2E.
Why is the K there?
It's like a kinetic energy. Not just energy, it's specifically kinetic energy. You can write it, or we'll just go with an E, one or the other. All right, how am I going to get this variable of E alone? What's your first instinct? Square, because the radical is alone. So I'm going to square. So this should be, we can do this without our calculator. What's 4 squared? 16. And if you square with 1 0, it makes 2 zeros. And then the radical is now gone. we're going to do this whole thing without a calculator. Algebra, what do you want to do now? Times by half. What is a half of 1600? 800. And now I'm going to divide by 2. So the final answer is 400 joules is the kinetic energy. Number 3, we have a thunderstorm and we got the wind going on in the storm. So this is a velocity and the P is the air pressure. So where is the air pressure? So the air pressure is the question mark. When the velocity is that. So the air pressure is the unknown. We know the velocity. All right, so let's plug in the velocity. Okay, what's your first move on this solving? We're going to have to divide because we want the radical alone. Okay, so in my calculator, I'm going to divide. Okay, I'm getting 8.6 da 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 da, and I'm not gonna round. So I have these dots, and these dots mean I'm working with my calculator. All right, now what's the next algebra move? I'm gonna square, because that gets rid of the square root. Okay, now do you remember I still had that on my calculator? So I'm just gonna go squared. It's gonna square whatever I had. I didn't round it yet. So 74.81. This whole time I'm keeping this thing on my calculator, okay? In grade 12, if you've rounded anywhere and you're off by 1,000th of a place, I have to take marks off from you. So it's good practice to make sure you're keeping things on your calculator. Okay, I'm going to minus the 998. And look, it's still on my calculator. So minus 998. So negative . And the one last thing is, how do I get P alone? Divide by a -1. So we're doing the air pressure and it's in millibars. So I'm not even sure what the abbreviation is, but I'm going to put the same as Manitoba because I don't know. Millibars is the air pressure. Okay, this formula talks about a grandfather clock swinging back and forth. Do you understand how a grandfather clock moves? The arm goes back and forth, back and forth. Okay, so what do we have here? The number of seconds in the period of the pendulum is the length of time to go back and forth once. This formula is what works. T is the period and L is the length. L is the length. T is the time. The time to do that. Back and forth is the T and L is the length. Okay. Todd wants to build this so that it goes back and forth every 2 seconds. So that's the time. How long do you want this arm of the clock to be? Okay, so I'm going to go 2 equals 2 pi . There's my formula. Okay, algebraically, I'm going to divide by 2 pi. Now, this in your calculator, I don't want you to be tricked. This is wrong if I type it like this. What does it do wrong? I need brackets. Does that make sense? Whenever you're doing dividing, making sure you're dividing by the whole thing if you need to. Anybody getting a 0.318 and change? 318. Okay, now I'm going to get rid of that square root, so I'm going to square. And do you remember that I left it on my calculator? So it's still there. So I'm going to square it. I'm getting a 0.101. That was good, the 0.101. All right, now that got rid of the square root, so I'm going to times by 32, and this whole time I haven't rounded a single thing yet. So times by 32, now this is the answer, so I can round it. So 3.24, what is the length? Feet? Okay, so this is a formula that says you can see out a distance according to what height you are. Okay, so you have sea level. So there's my sea level, 0. And you're on a tower, but the base of the tower is already 80 meters. So let's say the tower is on a hill. The tower is on a hill. Because they're already 80 meters above the sea level. Then you are on top of the tower. So D talks about how far you can see out, and H is talking about your height above the sea. So when you're doing this formula, just consider the 80 at the end of the question, because you are already 80 above the sea level. So just consider that at the end of the question. But that's what the situation is. That's your variables.